Hey folks, this is a quick, no actually it's not a quick video, but I'm going to go through a bunch of examples fairly quickly. You can always pause and rewind, etc. So that you slow me down a bit. But because I'm going to go through a bunch of scenarios, I'm going to try and do this somewhat quickly. So first of all, sometimes in math you're asked to find what the domain is, or, and I'll do this one in red, what the range is of a particular graph. Okay? So starting with domain, domain talks about where that graph is going left to right. Okay? So domain talks about how far that graph is going from left to right, or where that graph exists along the x-axis. Okay? Let's get the red pen out. And the range is not talking about left and right, as you might have guessed. It's talking about how far up and down that graph goes. Okay? So it's getting you to describe with a special notation the left and the right and the up and the down nature of a particular graph. Okay? So let me erase this here, and I got the blue pen. So let's start with the domain. I'm not going to write that each time, but we're just introducing it, so let's write it. So domain, once again, is talking about the x-axis. Okay? Now, if you look at this graph right here, if you were to take a walk along this x-axis here, this is our x-axis, and you were to look up or down, would you be able to see that graph? And if you were standing right here and you're walking along and you look up, yep, there's the graph. What if you were standing way over here and you looked up? Yes, you would see the graph. It would be very high up there. Okay? Same if you were standing over here and you looked down, you would see the graph still. In fact, there's nowhere you could go on the x-axis where you would not have the line that we see here, either above you or below you. Okay? So this graph, it really goes forever left to right. Okay? Now there's a special way of writing this, and that's what we're going to learn today. So start off with a D. D stands for domain. That's nice and easy. Then the equal sign. Then this is one of those few times in math you get to use your art skills to make a really cool bracket. It's this squiggly bracket. It's on your computer keyboard, just maybe above your enter sign. You probably never use this, but there is a bracket like this on your keyboard in case you forget how to write it. So it goes kind of like this. Now the notation in this case would be that because you can go anywhere along the x-axis and have the line above or below you, it goes forever left and right. Here's the way they would write it. They say x is an element of, that means it belongs to the real numbers. Okay, sometimes if you're doing the R in a fancy way, they put a little double thing there, but I just tell students the R is fine, a capital R, and then the squiggly bracket. That means this graph goes forever left and right, forever. Okay, it's part of the real number system. Okay, now let's go to range. Range is talking about the y-axis, and you could pretend you have an elevator and you're going up and down and you had to look, and if you looked out the window of the elevator you would always see this graph. No matter how high or how low you go, you will always see this graph. Okay, in other words, it goes forever down and it goes forever up. So the way you show that using this special notation for domain and range is you start with an R for range, your squiggly bracket. Can you guess what I would write in here? Well, you are correct, except for, just remember it's a Y instead of an X like we did up here. Y is an element of the reals, the real numbers. And my squiggly bracket wasn't so great there, but you get the idea. Okay, so if a graph goes forever left and right, this is what you write. If a graph goes forever up and down, this is going to be the range, okay, in the special notation. Okay, let's move to another question. Look at this parabola here. Let's talk about the domain first of all. Well, you start off by writing D, and then the squiggly bracket, And then what you do is you say, does this parabola go forever left and right? Does it go forever left and right? The answer is yes. You can see these arrows up here. That means it goes forever to the left and forever to the right. It's the same kind of question that we just did on the other page. X is an element of the reals. Okay? The range, however, is a little bit different. So let's look at the range. Does this graph, and I've got it all set up here, does this graph go forever up and forever down? Well, I hope you're telling me, no, this graph does not go forever down. It does go forever up. Those arrows mean it goes forever up. It does not go forever down. In fact, it goes down to the 3. It touches the 3 on the y-axis, and then it goes back up again. So, how do we show that using this notation? Well, the notation always starts with saying y is an element of the reals. However, there's a line there, okay? Y is an element of the reals. However, there's some restrictions we're going to put on this. We're going to say that y has to be greater than or equal to 3. Okay? So in this case, we know that it comes down, it touches the 3, and then it goes back up again. So this means greater than, and the line underneath means equal. Okay? Greater than or equal to 3. If it didn't quite touch the 3, then we wouldn't include this little line here. Okay? We would just have y is greater than 3. But a parabola, in this case, it does come down and touch the 3. We can see it. Okay? So that's what you do. This is what you do if it goes forever left and right. If something touches a certain number and then goes up in a certain direction forever, this is what you would write right here. Okay? We need to see some more scenarios, though, because it does get a little more interesting. Okay, let's start with domain. Here we have a circle. Obviously, a circle doesn't go forever up and down. Okay, so let's see what happens here. Start with the domain. Put the squiggly bracket. And start with the notation that looks like this. X is an element of the reals, but we're going to put some restrictions on this. So you put a line, a pretty strong line there. I don't know, it's not just a little line. We don't want it to look like a 1, okay? And then you say to yourself, how far left and how far right does this line go? Well, would you agree that the line goes, as far as the x-axis is concerned, okay, it goes from 1 and then it goes all the way over to 7. Okay, so it's between 1 and 7. So you could write it like this. You'd put a 1 there. Notice the 1 is a normal sized 1. That you don't want to confuse this for making this whole thing look like an 11 or anything like that. Okay, so you put the 1 there. You put the 7 out over here. Then we'll put our squiggly bracket. We're talking about x, so I'm going to put the x in between. Okay, now here's how you read this. X is greater than or equal to 1 because it goes all the way left and touches the 1. And x is less than or equal to 7. There's a symbol we have to use. And when you have a situation like this, you're going to write it like this, and I'll explain it in a second. It's kind of weird, isn't it? Okay, here's how you'd read it. You start in the middle and you say x is greater than or equal to 1. I know that you're used to seeing this symbol and saying this is less than, but when you're reading it this direction, we're not reading left to right in this case. We're starting from the middle and we're looking this way. X is greater than or equal to 1, and then you stay in the middle, back in the middle, and go to the 7. X is less than or equal to 7. Okay, it's pretty weird, I know, and that's why with domain and range in this notation, I find it really important to practice this stuff. Okay, and that's why I have a booklet that has a lot of questions that gets you to practice this, because it becomes easy once you're used to it, but in the beginning, this is pretty complicated or pretty strange. Okay, let's do the range. Now remember, we started off the same as we do all the questions. Y is an element of the reals. Then that line. Here's the restrictions though. Y is an element of a reals, but it's all the real numbers between 7 and 1. It's interesting. This circle happens to go as low as 1 and as high as 7. The numbers are almost, it's actually going to look very similar to the domain. That's a fluke because this circle could have been anywhere. But in this case, let's do it. So we've got 1 as our lowest point. 7 is our highest point. Then I write it in there. We're talking about y this time. And then you put these two symbols right here. Y is greater than or equal to 1. Y is less than or equal to 7. Okay? And that's how you write it down in a situation where there are endpoints on either side. Okay? There's endpoints. There's a maximum and a minimum, basically. There's a lowest point and a highest point. Okay, let's do another question. Okay, start with domain. Okay, a graph like this. People, it goes forever left and it goes forever right. We already know how to do the domain. X is an element of the reals and there's no restrictions. It just keeps going forever. What about the range? Well, in this situation here, start off by writing our y is an element of the reals. However, we need to put a restriction on this. It doesn't go forever up and down. It actually, now if you know anything about this kind of shape here, it's called an exponential graph. It never quite touches the x-axis. It's one of these weird things in math where something can approach, the blue line can approach the x-axis, but they never quite touch. It's something that happens only in math. It doesn't happen in real life. Of course, something approaching something else is going to hit eventually. But in math, it's kind of cool. You can always get closer and closer to the x-axis, but never quite touch. So in this case, y is going to be greater than 0 because it's going to be forever going upwards, but it's never going to touch that 0. So you're going to go y is greater than 0. You don't put that equal sign in there because it never quite touches 0, okay? And that's all the restrictions you need because y forever goes upwards. So y forever goes up at the point just above the 0. It never quite touches that 0. It's forever greater than 0. Never equal to, though. Okay, let's move on to another question. You can always pause and listen to that again. Here we go. Here we have two restrictions. Okay, let's get the blue pen. So for the domain, let's start it off. I'm just going to start it off as we're doing all of them. Let's talk about the restrictions. The domain, it goes all the way left. It doesn't quite touch -1. Why do I know that? Because there's an open point here. It looks like a little 0 or a little circle. That means it's not quite touching the -1. And it goes all the way to the right, and it doesn't quite touch the 3. Okay? So let's write the two numbers that it's almost touching. We've got -1 on the left and 3 on the right. So start by putting those in there. Okay, we're talking about x, and we put these symbols like this. I did not write the equal sign underneath because it never quite touches the -1, and it never quite touches the 3. So x is greater than -1 and x is less than 3. Let's do the range. It's the same situation. Y is an element of the reals with the restriction that the lowest number is -5 and the highest number that is on the y-axis is 3. Notice that it never quite touches -5. It never quite touches the 3. So write the smallest number first on the left and the biggest number, which is 3, on the right. We're talking about y here. So y is greater than -5. It does not touch. Do not put the equal sign. Y is less than 3. Okay. Let's see if there's some more examples here to do. Here's one. Notice on this question there's a closed dot here and an open right here. That means, well, let's do the domain right now. I'm just going to start it off and trying to go quickly so I don't bore you too badly here. Look at the farthest left point. Well, it almost touches the -5. And then it actually goes to the right until -2 and it touches the -2. So it's going to be a little trickier, but you do the same thing as before. Put the smallest number on the left, the biggest number on the right. So we go from -5 to -2. Put a bracket there. We're talking about x. So x is greater than -5, not equal to, and x is less than or equal to -2. Why did I put the equal sign? Again, just follow this pen. It's right here. It's actually touching this line here. It's not a circle, it's a closed circle or a closed dot. So it is touching that -2. All right, are you getting good at this by now? You might be able to take the video from here, but I can't ask you because you might be far away. So I'm going to keep going. So y is an element of the reals. What is the lowest value for y that you see here? I see -4. That's as low as it gets. What's the highest one? It goes up to 4. It doesn't quite touch the 4 though. So be careful. If your teacher is nitpicky, you want to be nitpicky yourself. So you start with the lowest number, put the biggest number for y. We're talking about y. We know there's going to be a symbol like this. The question is whether or not we have to put an equal sign underneath. Well, y is less than -4. Is it also equal to? Look back again. Yes, it is. So you're going to put that line in there. We're being nitpicky. Y is less than 4. Is that true? Yes, it never quite touches the 4 because of this little open circle there. Okay, that means it never quite touches the 4. We are done. Okay, is there another question? I don't see any more questions. All I see is space. I hope you have this stuff figured out, and if not, hopefully you will be smiling like this guy soon enough, because you will understand domain, which is talking about left and right, and range, which is talking about the up and the down of a particular graph. Have a great day, people.